HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman, hosted by Carl Franklin. This is Lawrence Ryan announcing show number 102, recorded live Tuesday, February 12th, 2008. Support for Hansel Minutes is provided by Telerik RED Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.telerik.com. Support is also provided by .NET Developers Journal, the world's leading .NET developer magazine. Online at www.sys-con.com. In this episode, Scott discusses the Entity Framework with Microsoft developer Mike Pizzo.
Hi, this is Scott Hanselman, and this is another episode of Hansel Minutes, and I'm fortunate enough to be sitting here with Mike Pizzo, a principal architect in the data programmability team here at Microsoft, and we are in Building 35. Thanks for taking time out of your busy day to talk to me, Mike.
Well, thanks for coming.
So you work on the team that produces the Entity Framework.
That's correct.
And I have personally felt a lot of confusion about which data strategy that I should, do my applications. When I sit down and I go file new and I get ready to make a decision, I've got LINQ to SQL, I've got ADO.NET, classic record sets. I've got these kind of things that I know, these new things that are coming out, and now I've got the Entity Framework to choose from. And I think that some people may have felt that LINQ to SQL and Entity Framework were not really complementary and that they were, competing ends. But I understand from talking to some friends in Building 35 that that's not the case. Am I correct in that?
Right. And there's certainly a lot of similarities between LINQ to SQL and LINQ to Entities, or the Entity Framework in general. And those similarities become very confusing. Before we talk too much about the similarities and differences between the two, it's probably helpful to define what LINQ to SQLs and LINQ to Entities are.
Yeah, I think that would be helpful, and I think it would also be helpful to understand to enable these technologies, what needs to be installed. Is this just put a DLL in a bin folder, or are these, downloads? How does this get on my system as well?
Sure. So the short answer to your second question, how do these get installed? Both LINQ to SQL and LINQ to Entities install as part of the .NET framework. So LINQ to SQL ships today as part of Visual Studio 2008 and is installed when you install Visual Studio. The Entity Framework will be part of an update to the .NET framework that will ship in the middle of this year. Okay. And so in both cases, the bits will be there.
So it'll be a service pack or a web download or some format, but it's part of the framework.
Correct.
Okay, so it's baked in. So at that point, I can choose either one.
Correct.
And these will be system-wide services. They'll be in the GAC, so I won't have to put anything in my bin folder. This is a add reference kind of a thing.
That's right.
And these don't involve, other than the compiler changes involved with LINQ, these don't involve any changes to the C# or VB compilers.
No, there's no specific code in C#, VB, or any of the languages or CLR specifically for either LINQ to SQL or LINQ to Entities.
So I know with LINQ to SQL, I can, in Visual Studio, my experience is such that I can go into the Server Explorer, I can drag tables and relationships over into a designer surface, and that designer surface is a pair of rose-colored glasses on top of some generated stuff. So if I have a products table, I'll get a products object. So there's often when people are doing LINQ to SQL, not always, but often there's a very straight link between the physical aspects of the database and then the physical aspects of my data access layer, products to products, and like that. Is that the way it works in Entity Framework?
The Entity Framework is very similar as a starting point. And actually, walking through that experience is a good way to talk about what's similar and then how the Entity Framework extends that and goes beyond that.
Okay.
So to back up and define some of our terms, the first term that we'll be using a lot is LINQ, which stands for Language Integrated Query, and is basically the ability to build your queries into the programming language. Mm-hmm. So historically, when you've programmed against a database, we have interoperable APIs for passing the connection information, for passing the query and retrieving results from the database, but the actual query itself was in the form of an opaque string. Opaque because the client knew nothing about the contents of that string.
Right, we were tunneling a language within a string.
Exactly, and it is a language. It's a full syntax language. It's almost a full program, but the compiler that you're using to write your application has no knowledge of the contents of that string. Mm-hmm. So you don't get statement completion. You don't get IntelliSense. You don't get any compile time type checking for the strings that you're passing. And what that means is that you can basically write your entire application. It will compile, and it's not until you execute it that you find syntax errors in your string,
right,
that you find you mistyped the name, that you did a typo or whatever. So no matter how good of a SQL programmer you are, there's always going to be errors in those strings. I make them all the time. time, and it's difficult to debug those.
Yeah.
So what LINQ provides is the ability to use objects as the metadata describing the metadata you're using when you're querying your database.
Right.
Well, LINQ is not tied to relational databases. LINQ is a general feature which allows you to program a strongly typed schema, where the metadata for that schema comes from objects themselves. So there's a couple different technologies for LINQ in the framework. The first is what we call LINQ to objects, which is simply the ability to build LINQ queries over any typed collection. So any of your IEnumerables or iCollections, any list in your program is now queryable with Visual Studio 2008. We also have implementations of LINQ against XML, which allows you to write strongly typed queries against XML.
Right. I love that stuff.
And now we're introducing LINQ to SQL and LINQ to entities, and as well as LINQ to dataset. And
okay, so there's three things to understand here. There's LINQ to SQL from a data perspective. There's LINQ to entities, and then there's LINQ to dataset.
Correct.
Okay.
Correct. So we'll try to touch all three of those.
Deal.
Historically, the greater confusion has been between LINQ to SQL and LINQ to entities, but LINQ to dataset certainly comes into there. So we'll try to cover that as well.
Okay.
So LINQ provides this programming experience for building strongly typed queries against any iQueryable provider. So there's an interface called iQueryable, which is similar in nature to IEnumerable. IEnumerable is an API that a collection can implement and gives a common way for applications to iterate over that collection. And in fact, the languages built on top of those language syntax, such as the for each statement in both VB and C#, are basically just sugar over calling that IEnumerable and looping through those results.
Right.
In a very similar way, iQueryable defines a set of query operations, and then in VB and C#, there's syntax sugar that allows you to have very nice query syntax for building queries that end up calling that underlying iQueryable implementation.
Okay.
So when we talk about different implementations of LINQ, what we're talking about is different implementations of iQueryable.
Okay. So when I think about things like people have released LINQ to Amazon Web Services or LINQ to Flickr, they're converting those iQueryable lambdas and turning them into something that is appropriate to that underlying data source.
Correct.
Okay. So that makes sense.
All right. So getting back to LINQ to SQL, what is LINQ to SQL? LINQ to SQL is an implementation of that iQueryable interface over a SQL Server schema. And the design experience becomes very nice, as you say. If you're trying to query against the SQL Server schema, you can start up Visual Studio, select LINQ to SQL project, and you get a nice design experience where you can drag on tables, and dragging on tables allows you to generate classes for those specific tables.
Right.
So they're pretty much one-to-one. You can change the naming. So if you've got some obscure column name, you can provide a more friendly name. You can, if you have, one thing that relational databases don't do well is describe inheritance hierarchies.
Oh, yeah.
And so that's often modeled in a relational database by having a single table which has discriminator columns where the discriminator specifies this particular row represents this subtype or this other subtype. So LINQ to SQL does let you map an inheritance hierarchy to that single table with a discriminator column. The other thing it does is it allows you to map relationships to foreign key columns. But for the most part, it's a pretty direct one-to-one mapping. What you drag onto the design surface is pretty much the set of entities that you have to program against.
Okay, so does that mean that it provides a layer of abstraction but not necessarily a strong layer of indirection?
Yes.
Okay.
So you really are generating queries directly against the underlying schema when you're using LINQ to SQL. But it gives you a very nice experience that not only allows you to query in terms of strongly typed objects, but also those objects are returned as CLR objects that you can then make changes to. Those changes are change tracked, and then later you can call save changes, and it'll generate the right DML statements or call stored procedures, depending on how you've configured
DML being the markup language that is describing the database underlying.
DML being the data manipulation language, which is the inserts, updates, and delete statements that you use in order to modify relational tables.
So there's DBML.
Yes.
Which is describing that diagram. It's the XML file that makes the diagram look like that.
Right.
And then there's DML.
Right.
Which is what you just described.
Yes, we have far too many 3-letter and 4-letter acronyms.
But, well, this is one of the things. I mean, Visual Studio is a pair of rose-colored glasses, and there's nothing wrong with wearing those glasses. I kind of like looking at the world that way. But every once in a while, you want to just open that guy up in Solution Explorer and see what's happening underneath, just so you know that no one's trying to fool you.
Yeah, it's the same as the power of HTTP. I mean, HTTP is
Exactly.
great. You generally don't need to look at the HTML and understand everything, but it's nice to have there, and it's nice to look at now and then.
Exactly. And that's the kind of stuff that I want to understand. So when we start talking about linked to entities, there's magic happening, and I choose to live in that matrix. But I want to be able to peek underneath and see what's happening.
Yep. So that's sort of the LINQ to SQL experience, and it can best be summarized as a strongly typed experience over a SQL Server schema. So it gives you the ability to query in terms of LINQ, bring back objects, modify those objects, and save changes to those objects.
And as you said before, this is using the metadata in the SQL Server that was already there, and we're just kind of bringing it up into a more consumable format. This is the kind of stuff that a lot of progressive people in the early 2000s were doing with code generation.
Yep.
Taking a look at a database saying, hey, that looks like information I already have. Let's flow that up towards into a CLR object.
And specifically, the design experience within Visual Studio does generate classes. And as I alluded to before, those classes provide the metadata that LINQ uses in order to do the strong type checking of your query as you build it.
Cool.
So the LINQ to entities experience is very similar to start with, and that's one of the reasons for the confusion.
Okay.
Once you install the entity framework, we also have a design surface, and you'll be able to select from the Add New Item templates a ADO.NET data model. And when you select that, you'll have a wizard that allows you to select the tables and the views and the stored procedures that you want to bring into your project. And again, you'll have a design surface. That design surface by default will generate entities which are one-to-one with the tables, views, or stored procedures that you've selected. But that's sort of where the similarity stops.
And unfortunately, this is where I think a lot of people stop themselves. They go, what is this?
Right. So the next step that you can do is you can view the mapping details in the entity framework.
Okay.
And here's where you really have a lot of control over how you map your entities or your objects as they're instantiated within the .NET framework using linked entities, how you can modify how those map to your underlying relational schema.
Okay.
So to back up a step, LINQ to entities is LINQ over the entity framework. And the entity framework is all about something we call the entity data model. And the entity data model is a conceptual model that allows you to think in terms of entities and relationships that more closely reflect the real-world concepts that you typically deal with in an application. So a relational database has tables, and it has constraints. And that's really about all. It doesn't have the concept of a relationship. It has foreign keys, which are constraints, and they're a little bit different. They're not exposed to the query language, so there's no easy way to navigate a foreign key. You have to create a join. It doesn't have higher-level modeling concepts such as inheritance. It doesn't have some of the other things that you would typically have in a higher-level programming model. So the entity data model is an entity relationship model that allows you to define entities that is types that have a specific identity. Those types can have inheritance. They can be mapped, or you can have relationships between your types. And those are strongly defined relationships. That is, we understand characteristics of the relationship, such as cardinality. They're not just CLR references that have no meaning in the model. And then you can have other higher level concepts like complex types. That is a member that has like an address field, which may have multiple members itself, first name, last name, city, state, and zip, for example. These are also called composite types sometimes.
Okay.
And then you also have things like many-to-many relationships. So the first part of the entity data model is defining this conceptual model. And that's what you can do in the design surface. In fact, with the entity framework ADO.NET data model designer, you can either choose to start with a database and generate a default model from that database, or you can start with a clean slate and just design your entities from scratch to have the entities and the relationships that you're interested in.
Okay, so this is like using that design surface as your kind of ER studio.
Exactly.
Okay.
Exactly.
And so the way I'm kind of put this in my own head, I'm trying to model this in my own brain, is that there's the physical aspects of your database, which can be modeled via LINQ to SQL, and there can be some mappings, but for the most part, what's going on in your database is what's going on in the objects when they LINQ to SQL world. But that extra layer of indirection is basically saying that there's the physical characteristics of your database, which are not always the logical representation of your data model. You may have this logical concept in your entities of products, but products may be inside of 3 different tables, and they may look entirely different.
Right. So
and you're shielding them from all those.
Right. So the entity framework is an implementation of the entity model over a relational store, over an ADO.NET data provider.
Okay.
So what we've done with the entity framework is we've expanded the definition of an ADO.NET data provider so that other data providers besides SQL Client can plug into this framework.
Okay.
And the way that we've extended it is basically by providing a mechanism whereby we can pass a query in a canonical form as a syntax tree, an expression tree, and the provider generates their provider-specific SQL out of that syntax tree.
Ah, okay.
So that's how other providers can plug into the entity framework. One layer above that, we have something called the entity client, and the entity client is an ADO.NET data provider, so it has a connection, a command, and a data reader. You can actually program against it directly without generating objects and without using LINQ.
Okay, so in this instance, ADO.NET is not talking to the SQL data provider, but talking to the entity client data provider, which is providing that layer of abstraction?
And the entity client data provider is in turn talking to either the SQL client, the SQL Server data provider, the Oracle client, the DB2, or whatever other provider.
Okay, so let me see if I have an understanding of this. I'm up in a client application, and I'm doing linked entities. I've described my logical data model, and then I send something off via linked entities. That gets translated into an iQueryable interface, which is then interpreted by the entity client. The entity client then talks to its ADO.NET provider, which then takes that abstract syntax tree and it passes it along to either the SQL provider or the Oracle provider, translates that into either T-SQL or Oracle SQL, and then along and then back.
Right.
And then the record set, of course, follows all the way back.
Right. And so that's all a part of the magic that goes on under the covers. Now, you as the programmer within Visual Studio don't need to think about or see any of that. That's all sort of wired for you as part of this entity framework experience.
Right.
So within the designer, now you can specify more complex mappings between the entities that you have in your entity model and the actual storage in the database. So for instance, you can map multiple tables to the same entity. Or you can map multiple entity types to the same table. Or you can map many-to-many relationships that take out the join table.
So you just said I could do multiple entity types to one table. So I could have a table of, of products, but I really wanted to have, let's say I had different entities, products and discounted products. And based on some flipped bit in a column somewhere, I wanted my entity model to look entirely different, where someone could get back a list of products or a list of just discounted products, even though they're being stored in a single table.
Correct.
Yeah, I can see where that'd be more challenging to do that in another, the old-fashioned way.
In this example of products and discontinued products, it's likely that there would either be the same entity type, but different logical entity extents for those. That is, the type may look the same.
Yeah, maybe not a good example.
But there are different entity sets, and the entity framework does support that. So that's a great example for a different mapping concept. A similar concept would be inheritance, where maybe a discontinued product has the date it was discontinued. So that's not a completely different type, but it's derived from that type. And again, you may have a different extent for it, or it may just be when you query the products extent, you ask specifically for discontinued products, or you specifically filter out discontinued products. So in fact, with both LINQ and with a variant of SQL we call entity SQL, you can use the type information as part of your query because, again, the type information is part of the entity model. It's part of the model that you're working with at the application layer. So in addition to being able to, perhaps a better example of mapping multiple types to the same table, the extreme example of mapping multiple types to the same table is a scenario we call the universal database scenario. And so a highly normalized database is one in which there are multiple tables and there's no redundancy of information. There's you find a high number of tables with a lot of foreign keys relating all these different tables.
Those are usually pretty hard to read.
They're very hard to read, and again, they're not the model the application wants. And so the entity framework allows you to have flexible mapping where you take what's in multiple different tables and where they logically represent one type or an inheritance of type. That's the model that the application works with through the entity model. So that's the first half of that. The other extreme to that highly normalized schema is a single table where all of your types are stored. And in this case, it's a single table. There's, again, usually a discriminator column that says this type is a customer, this type is an order, this type is an order detail. In this case, there's no necessarily any commonality between these different types stored in
Right.
the single table. So you've got columns, a very sparse table where some columns are used for one type, some columns are used for another type. Again, that's not a very convenient model to program against from using your application. But the entity model and the entity framework can actually model, the same customer order detail, either highly factored into these normalized tables, as you typically see in a specialized enterprise database, or the same model can be mapped to a single table where it actually uses a discriminator to specify the different types. So that's just an example of some of the flexibility of the mapping defined by part of the entity framework.
Yeah, I mean, I've got like a tear coming down my eye here because I'm thinking of a particular database that I've worked on where it was going to be, the grand database plan, right? It was the end database to end all databases. And, you started out with the person and then suddenly address and then, there's multiple addresses and billing address and mailing address. And then we started to blow the address apart and that became different postal codes and it got more and more and more complicated so that the concept of a person was like, literally spread across like 9, 10 different tables. And then you start relating them to accounts. And the programmer, the poor guy who's got to just get that data grid filled up on the client side, he's like, just give me a person, right? Where's get person? Can I just have a person object, please? Well, no, you have to go and retrieve this. And then you start getting into issues like lazy loading, which would be something I'd be interested in understanding. Like a person might have an address, but perhaps it's in another database somewhere. Do I get a person object back and he has an address object and I don't go and access that data until I access that property? What about those can you have sparse objects?
Yeah, so these are all great questions.
Sorry, I'm rapid firing. I'm thinking, how can I use this tomorrow?
Yes, so backing up a little bit, just to elaborate on your example, not only does it become difficult for the programmer to write the code that figures out how to get the information for their logical person out of 12 different tables, but that code is very, very brittle and very, very hard to read and maintain because it has a lot of implicit knowledge baked into these string queries, so it's not even something that we can reflect on and understand.
Or refactor
that depends on the physical layout of the database. So later, if you change some field in the database, it's going to totally disrupt the queries that you have in ways that are difficult to track down and understand. So part of the beauty of the entity framework is not just that it provides these mapping capabilities, but those mapping capabilities are specified declaratively through a mapping file. And if you decide to change the underlying store, if you refactor things or renormalize or denormalize your tables, you can modify that mapping. And in fact, you don't have to regenerate, rewrite, or even recompile your application. It continues working because it's working in terms of this conceptual model and the classes that were either generated or handwritten to reflect that conceptual model. And those are being declaratively mapped through this mapping file to your particular storage schema.
Now, this doesn't seem like too thick of a layer. It sounds like there's a lot going on, but it doesn't appear to me, in thinking about the stack and trying to visualize it, that there's a huge distance between myself and the database. Is that the case?
That is in fact the case. And really to understand how this works, the typical approach to doing ORMs is to sort of do query rewrites where you get a query in and you apply a set of transformations to that query.
Right, because I'm familiar with a number of open source ORMs that I was going to ask you about how you relate to those guys.
Right. So typically in those scenarios, there's a fairly straightforward set of transformations. And if you decide to add a new mapping concept, you go and you implement a new transformation. And it sort of goes through and when you start off and there's only 3 or 4 transformations where you're changing names or doing inheritance or something like that, it's pretty straightforward.
Right.
But as you add more and more transformations, like being able to take one entity and map it to multiple different tables, the interaction between those transformations starts becoming very complex and very difficult to manage. And it's even harder when you try now to send updates through the same pipeline because you have to sort of write the reverse transformations for doing the update pipeline. That was my next question.
The updates issue is always a problem where it's look how easy it is to get the data. And then you've got to figure out how to put it back in the right order.
Right. And so what the entity framework really takes sort of a novel approach to how it does this mapping, and it does it through something we call client views. And client views are basically similar to relational views in that we define view to represent your entity set and a query in terms of this entity SQL, this canonical syntax that I had mentioned before, that transforms that conceptual query, the query against the conceptual view, into the query against the actual storage tables. Now, it's important to understand that those views are generated at design time.
Okay.
And then when you pose a query to the system, we go through an expansion phase where we replace references to the entity sets, the conceptual entity sets, with these generated queries that are in terms of the actual storage schema.
Okay.
Now, we don't do any query evaluation on the client. We just do this simple expansion step on the client, and then we pass the query down to the back end. The back end then is able to take that query, which is now in terms of the storage schema, and do what it's good at, which is executing that query and returning us the results.
And that doesn't put up too much pressure on the client as far as performance or
So
memory.
there's, as far as performance is concerned, there's sort of 3 areas to think about.
Okay.
The first is loading the metadata associated with the model and the transformations to the actual storage schema. And so there's a fair amount of metadata that needs to get loaded, but that only has to happen once. And we've made a significant investment in caching that metadata and even compiling. We've done some work with trying to compile the metadata and those transformations so that to minimize that hit.
Okay.
The second hit is actually the query transformation. So you're getting a query that is represented in this canonical manner, and eventually that ends up generating SQL. And it's a fairly straightforward path, but there's certain steps involved, and that can be expensive. So the investment there is, again, to do compilation of those so we can compile the query so that at runtime, step back. When we talk about compiled queries, it's not design time compilation, but basically...
They're kind of jitted queries.
Exactly. The first time you use it, we can compile it, and then you can reference a compiled query for repeated exexution.
Do you have to do that yourself, or is that handled for you? How much? I guess what I'm trying to understand is how much awareness does a client of this have to have?
So at the LINQ level, if you want to use compiled queries, there's a mechanism for you to create the compiled query and then call that compiled query as if it were a method that may be parameterized.
Okay.
So you don't have to think about, I've got these different layers and how do they interact and how do I...
You just define
it's fairly straightforward. Okay. But yeah, you do define, this is a query that I'm going to call multiple times. Okay. So I want you to go through the work of compiling it and giving me a very fast access path.
And this is not uncommon for things like XSLT or regex. I mean, there are those things that cost on the client. We know that there's a client library. You can use it as per usual, or you can hang on to one and then use that compiled one.
Right.
Okay.
Right. So compiled queries give us the ability to sort of factor away that for repeated execution.
Okay.
And the final stage is the materialization of the objects. So if you're using LINQ to SQL or LINQ to entities, we at some point are getting records out of the database, and we need to transform those into CLR objects. Again, we do a lot of work we do something called lightweight code gen, which is we generate the actual property setters and object constructors to make it as quick and efficient as possible to retrieve those objects and generate them. But there is some overhead because you're representing your results now in terms of an object as opposed to a standard ad hoc record. So we've done everything that we can to try to optimize that scenario as well.
Okay.
So the end result is, as you say, even though a lot is going on under the covers, it's all pretty straightforward. And at runtime, we've got a very efficient path through the stack. Now, this is true. The compiled queries and the result materialization are true both for the LINQ to SQL and the LINQ to entity stack. It's arguably more important in the LINQ to entity stack where we're doing more sophisticated transformations, but I wanted to be clear that was a feature of both stacks.
Now, how much pressure is there on the part of the person who is writing one of these providers for a particular database to affect performance? I mean, if I'm going to go and write the MySQL entity framework provider, it appeared from what you were describing that most of this stuff is happening outside of that person's control. So there's not a whole lot that they can do in the creation of their SQL from the abstract syntax tree to kind of screw it up.
Right. So that's true. And in fact, we have been working with a number of providers. We've had a couple different what we call provider fests, where we've had provider writers come in-house, and we've worked with them specifically on understanding how to take that syntax tree and generate the SQL. And in fact, it's been a fairly straightforward process. We've had great success with that. There's not a lot that the provider can do in that path that would affect performance. other than to think about the types of SQL that they generate. So there may be optimizations where in the common syntax there is a particular operator, and there may be different ways that they could translate that operator into SQL when they generate the SQL.
So they would want to do the one that's the most efficient for their particular platform.
Correct. And in fact, for SQL Client, we have a flag internally that tells us whether we're generating SQL for SQL Server 2005 or 2000 or 2008, and we may generate slightly different SQL for the different backends to optimize for that particular backend. But that's a fairly minor optimization in terms of the overall path. The other thing we found is that the query processors do a pretty good job of optimizing the queries once they get in the database. So I was doing some experimentation where I was trying to figure out ways to provide hints or rewrite queries in order to generate better patterns that were then passed down to the store. And although I could affect the length of the queries that were generated,
make them more aesthetically pretty.
Right, exactly. Typically, the overall performance of the queries didn't vary much because the plan compilers in the database were so good at recognizing the patterns, caching that pattern, and then re-executing it multiple times.
I remember I used to spend hours and hours trying to get my certain sense of aesthetic, my own brand of aesthetic inside of the SQL, and it sounds like that as I'm spending these hours trying to make it prettier, of course, hours are being spent on the SQL processors to just make it faster no matter what it looks like. So
right. In some ways, it was relieving to see that the framework and the database were doing such a good job. In some ways, it was humbling because I wanted to have more control over it, and I found that even my best efforts were normally not worth the effort.
Well, there's the loss of that aesthetic. I mean, there are SQL aesthetes out there, and I respect them. And from a performance perspective, I assume all the regular things in making a database better as far as good use of indexes and clustered index, and you can still run the profiler and look at the query plan. And what if the query plan doesn't look right and you feel that it's doing something inappropriate and you don't like how that SQL went down because the query plan isn't efficient?
So in cases where the query plan isn't efficient, oftentimes it has to do with those things that you were just mentioning. Do I have a good index? Do I have a good physical layout of the database? Is it lending itself well to those queries? If that's not the case, if things are well set out and it's just the queries that are being generated, then you can play around a little bit with the way that you build the query to try to optimize it, much as you would if you were just passing a string down. But in most cases that we've looked at, it's more a case of how the database is set up than how the queries themselves are being generated.
Now, just as we wrap up here, at the very beginning, we also talked about LINQ to dataset, and you were going to touch a little bit on that. Yeah.
So LINQ to dataset is basically taking the existing ADO.NET dataset, which is an in-memory relational cache, and LINQ enabling it.
Oh.
So since we came out with the ADO.NET dataset in version 1.0.
LINQ to dataset. See, I thought it was something much more mysterious.
We're getting trickier in our naming. Since ADO.NET 1.0, people have loved the dataset as a means of moving data with changes back and forth across the web, as a way of aggregating data from multiple sources, as a way to bind and interact with data in memory in a very rich way. And one of the biggest requests we've had since ADO.NET 1.0 is better queryability over the data once it's in the data set. And so by LINQ enabling the data set, we're not only giving you LINQ, but we're also giving you query. So the first time you're able to really write within the data set queries that join different tables within the data set. And in fact, you can join the tables within the data set with collections that you have outside of the data set. You can invoke CLR methods as part of your query. Okay. It's a very, very well integrated query experience for really using the data that you have in the data set. So the use cases don't really change. The scenarios that you use data set in the old days are still scenarios that you'd use data set today. We've just now enhanced that experience by adding LINQ to it. The scenarios where you used to use data readers and would in all likelihood end up generating your own objects and populating those objects and so forth, is now done for you with LINQ to SQL when your objects directly represent the schema of your database and you're going against SQL Server, or with the Entity Framework when you want to work with a richer model that has more flexibility in how it maps to the relational store.
Okay, that makes a lot more sense. When you started talking about the data reader, and I've written just thousands of lines of that code where I'm spinning through the data reader and going, basically shuffling the deck. I like to say, this one goes here and that one goes there and column 0 goes there. Da, da, da. Now, full disclosure, though, I know that some listeners are going to chuckle because I wrote an essay a number of years ago called Returning Data Sets from Web Services Are the Spawn of Satan and the Root of All Evil. So when you said data sets, I've used data sets a number of times for WinForms applications, for binding and stuff like that. But I always get worried when data sets get passed around inside of web services as a result. Which one of these 3 technologies would I want to use if I wanted really nice XML to be passed into a web service? If I wanted to take that object and then serialize that tree, that object graph, would it be? Could I take those linked to SQL? Those linked to entities objects, mark them up with XML serializable, and then pass them along their way as angle brackets?
So the generated objects, both in LINQ to SQL and LINQ to entities, are serializable. Mm-hmm. That said, what serializes is the current values of those, not the original values. So today, with both LINQ to SQL and LINQ to entities, there's additional work that you would need to do in order to transport the original values, that is the change set, that you get with the diffgram, the dataset diffgram today.
Okay.
Now,
which is the thing that you get if you do, in fact, pass datasets, because
Correct.
You're getting that extra bit of context. That makes sense.
Now, if you are trying to write a data service, that is, what you're trying to expose is a rich way to interact with your data, then the technology to look at, which I know you've had a previous podcast on, is what we used to call Project Astoria and is now called ADO.NET Data Services. And ADO.NET Data Services basically build on this entity data model and allow you to not publish just methods for calling in and getting back a fixed set of results, but actually to publish your entity model and allow the application to query that entity model through a REST-based, a very natural URL-based mechanism that identifies the particular resources within that entity model that you want to query.
Okay, so now it's all coming full circle for me now. So then if I'm doing entity framework work and I want to start exposing it, then it is Astoria and the ADO.NET data services, I guess. I like calling them by their code names, so it's easier, that I would want to expose. So that would make sense then. Yeah,
so the ADO.NET data services technically are able to query over any iQueryable interface. So any LINQ-enabled provider you can query over. Now, if you want to do updating against the data source, you have to implement an additional interface called iUpdatable. And then there's other functionality that we're looking at adding over time, which will require other incremental investments. Now, the nice thing about the entity framework is we will have an implementation of all of these interfaces directly over the entity framework and a very nice design experience where you can walk into Visual Studio, you can create your entity model, and then you can go in and create your ADO.NET data service, point it to that entity model, and specify these are the entity sets that I want to expose, and you're off and running. You have a data service that can be called from any HTTP client. You can then go beyond that and start adding additional service operations, additional interception, a lot of other features that ADO.NET data services have built in. But it's a great experience. And part of the promise of the entity data model is building on this common model, not just the ability to have LINQ expressions that are mapped to a database, but to build a whole framework around services, around other components that work in terms of this conceptual model.
So this could, I'm sorry, I'm actually kind of pause. I'm just giving me pause. And whenever I have conversations like this, I start kind of mentally drawing the stack. And I'm going to have to go draw a picture about this and blog about it, because suddenly what I thought was a lot more complicated stack got a lot simpler.
Great.
You know, sometimes it just seems so wide. I mean, I'm wandering around Microsoft and someone's always working on something, and I always worry that these things don't interoperate, they don't work together, and it freaks me out a little bit. And the way that I go and try to get a better understanding is I talk to people like you, and then I go home and I draw a picture.
Yeah, well, I was very nervous about doing this webcast because as an architect, and an Italian, I speak with my hands, or I draw on the whiteboard.
That is true. You are
and trying to understand how to communicate some of these concepts without being able to draw on my whiteboard was a little bit intimidating.
That's okay. I will add a proper slide with explanation of what this looks like. I really appreciate you taking the time to sit down with me today. This has been another episode of Hansel Minutes, and we'll see you again next week.